Good morning and welcome to my channel. Today we'll be looking at connection of solar panels in series. Connection of several solar panels in series arises from the need to reach certain value of output voltage without changing the current. When panels are connected in series, they are referred to as a string. To connect solar panel in series, all we need to do is to leave one of the terminal, which is the positive terminal, and go to the negative terminal. Connect the negative terminal of the first panel to the positive terminal of the second panel, then the negative terminal of the second panel to the positive of the other panel, and we continue the connection until we get to the last panel and leave the negative terminal hanging, such that it is between the first positive terminal and the last negative terminal we now measure our respective value of current, value of voltage, and the power. In this lesson, we are going to look at 4 different ways or 4 different conditions in connecting panels in series. The first we are going to look at is to connect panels in series that have the same parameters. That is, they have the same voltage, they have the same current, and they have the same power. Then the second condition we are going to look at, which is condition number 2, is to connect solar panels that have different voltages and they have the same current value. Then the third we are going to look at is to connect panels in series that have the same voltages but different current. And the last we are going to look at is connection of panels that have different wattage. So we'll look at the first using this example. Assuming we have 3 panels of the same voltage and current. As we can see, we have 12 volt 5 amps, 12 volt 5 amps, 12 volts 5 amps. So when these panels are connected in series, what will be the total output voltage, what will be the total output current, and what will be the power? Like we earlier said, when panels are connected in series, we connect them in series in order to increase our voltage and leave our current value constant. So in order to analyze this example, all we need to do is to add the voltage of the individual panel in series. So I have V1 plus V2 plus V3. We have 12 plus 12 plus 12, we have 36 volts. And since the current remain constant, so we take the current value of one of the panel, which is 5 amps, as the current, total current in the system. So to get the power is equals to current times voltage. So we have 5 times 36, we have 180 watts. So this is the total voltage produced when connected in series, this is the total current produced when connected in series, and this is the total power. This is a condition that exists when the voltage and the current value for all the panels are the same. So we'll go to the second example. When the voltage rating of the panels are different but the current value are the same. For example, I have 6 volt 5 amps, 12 volts 5 amps, 12 volts 5 amps. So in this case, it's the same approach. All we need to do is to add the individual voltage of the panel together. Then since the current value are the same, we take one value of the current to be as our total current. So that's exactly what is here. So we have 6 plus 12 plus 18, we have 36 volts. Then we take one value of the current, which is 5 amp. Then 5 times 6, 36, we have 180 watts as the total power. Go to condition number 3. Condition number 3 is when all the voltage value of the panels are the same, but the current value are different. For example, we have 12 volts 1 amp, 12 volts 3 amp, 12 volts 5 amp. So in this case, you may want to assume that since it is like this, we can easily get the power by multiplying each panel voltage and current. So we'll take the first panel, 12 times 1, we have 12 watts. Panel 2, we have 12 times 3 is equals to 36 watts. Then we have panel 12 times 5 will equal to 60 watts. So when you add all this power together, we'll have 12 plus 36 plus 60 is equals to 180 watts. But this is not the case, because when panels are connected in series, it is the panel that have the lowest ampere rating that will be selected as the current of the string. So in order to solve this example, all we need to do, since the voltage are the same, we add all the voltage 12 plus 12 plus 12, which will add 36 volts. Then we look at all the panels that were given. The panel with the lowest ampere rating is the panel that takes charge of the series. So the panel that have the lowest ampere rating is 1 amp. So when we multiply 1 amp by 36 volts, we have 36 watts as our output power. So you can see that in this case where panels are connected in series and they have the same voltage but different ampere rating, is not a right way of connecting panels in series, because if that is done, like the example we did now, we discover that the power of the string, the actual power of the string, is supposed to be 108 watts from our calculation. But because of the fact that one of the panel have a lower current rating, that is no longer going to exist. But what now happens? The total wattage of the arrangement is going to be 36 watts. So you discover that about 33% of the maximum power in this particular string has been, the power produced by the string has been reduced by a whole 33%. So that is why it is not advisable to connect panels of different current rating in series. So let us look at the last example, solar panel in series of different wattage. Fine, it's the same thing. This one is clear. They are already connected in wattage. So all we need to do here is to add all the individual wattage. For example, this one is 40 watts, this one is 100 watts, this one is 100 watts. So like you want to assume, if you connect them, you have 320 watts. But fine, this is not the case. As long as they have different wattage, the best way to look at it is to apply Ohm's law to get the maximum current that is produced by each panel. So for panel 1, all we need to do, divide the power of the panel by the voltage, we get the current. Panel 2, the same thing, wattage all over voltage, we get the current. Panel 3, wattage all over voltage, we get the current. So now after doing this calculation, we are going to get the panel that produces the minimum current. It is this panel that will take charge of the string. So we now go to the next step. All we need to do, look at the panel. Since they have voltages and we are working in series, all we need to do is to add their individual voltage. So we have 6 plus 12 plus 24, we have 42 volts. Then now to get our power, we take the current that is produced by the small panel, current times voltage, 42, we have 280 watts. So you can see that in this arrangement, the actual power that is produced by the string is 280 watts instead of the 320 watts that we want to assume. So simply meaning that 12% of the power have been reduced. Instead of using 320 watts, we are now using 280 watts from the string. So the same thing applies. So it is very important to know that before connecting panel in series, they must have the same voltage and current, and 2, they can have different voltages but the same current. So the emphasis here is that no matter the panels you want to connect in series, what you must pay attention to is the current. They must have the same current. Once they have this different current, no matter how large the arrangement is, the connection is, it is the panel that have the lowest current rating that will take charge of the string. So you can try this example to get a proper understanding of this series connection. So if you find this lecture helpful, you can like and give me your comment on the comment section. Stay tuned for more interesting videos. Thank you.